Have you ever turned on a flashlight and tried to race the beam? Of course not. Light is so blindingly fast that to us it feels instant. For thousands of years, the brightest minds in history, including ancient philosophers like Aristotle, believed light just existed everywhere all at once. They thought it took absolutely zero time to travel. So how do you even begin to measure something you can't catch? And more importantly, why did humanity even try? Welcome to Simple Things Surprising Histories. Today, we are looking at the bizarre story behind why we measured the speed of light. To understand the why, we have to go back to the 1600s. At this time, measuring light wasn't a priority. Surviving the ocean was. European empires were sailing across the globe, but they had a massive, deadly problem. They couldn't figure out their longitude. Without knowing exactly where they were east to west, ships were quite literally crashing into continents. To solve this, astronomers came up with a wild idea. They decided to use a giant cosmic clock. They looked to Jupiter. Specifically, they tracked Jupiter's moon, Io. Io circles Jupiter like absolute clockwork, disappearing behind the giant planets at very predictable intervals. The plan was simple. If sailors could use a telescope and an almanac to predict exactly when Io would eclipse, they could figure out their exact time and therefore their exact location on Earth. It was a brilliant plan. There was just one tiny universe-altering glitch. Enter a Danish astronomer named Ole Romer in 1676. Romer was closely watching Jupiter's moon to make these navigation charts, but he noticed something infuriating. The cosmic clock seemed broken. When Earth and Jupiter were orbiting close to each other, Io's eclipses happened exactly on time. But months later, when Earth orbited further away from Jupiter, the eclipses were late, sometimes by up to 22 minutes. Most scientists brushed it off, thinking the moon's orbit was just weird, but Romer had a staggering realization. Io wasn't changing its schedule. The light bouncing off Io was just taking longer to reach Earth because it had to cross a greater distance. For the first time in human history, someone proved that light wasn't instant. It had a speed. Romer didn't have the perfectly accurate numbers we have today, but his math showed light traveled unimaginably fast. The quest to measure it had officially begun. Once Romer proved light took time to travel, scientists became obsessed. Over the next 2 centuries, they moved from looking at planets to building wild contraptions. In the 1800s, a French physicist named Hippolyte Fizeau literally shot a beam of light through a rapidly spinning toothed wheel across the city of Paris to measure its exact speed. But why did getting the exact number matter so much? Because the speed of light ended up being the master key to the universe. In the 1860s, James Clerk Maxwell used that exact speed to prove that light, electricity, and magnetism are all the exact same thing. And decades later, Albert Einstein used that measurement to prove that the speed of light is the ultimate speed limit of the universe, binding space and time together in his famous equation, E equals mc squared. We started trying to measure the speed of light to stop wooden ships from sinking. Today, knowing that exact number, 299,792,458 meters per second, is the only reason our modern world works. Every time you use GPS on your phone, your location is calculated by timing how long radio waves, which travel at the speed of light, take to reach satellites. From the optical fibers bringing you this very YouTube video to exploring the furthest galaxies, it all traces back to a Danish astronomer watching a tiny moon in the 17th century. If you enjoyed this journey through time and space, please hit that like button, share this video with a curious friend, and subscribe to Simple Things Surprising Histories for more fascinating stories hidden in plain sight. Thanks for watching, and I'll see you in the next one.